Okay, so welcome everybody. Today what we're going to be focusing on is why we have seasons. You should have some understanding right now of why we have seasons. We're going to step it up. We're going to take it just a little bit further. I'm on my second computer, and what I'd like to do is draw a picture with you. Give me 1 second as I figure that out. So at this point, you should have some kind of basic understanding of why we have seasons. And you should also understand that there are many misconceptions of why what people think. And I loved reading your work about like what you thought based on the work of Private Universe. All right, so one more thing. I'm going to go to Ben's website. I love this website, Ben. You are the boss for teaching me this. All right, so let me get rid of this ad so I don't have to look at it. No. Okay, ready? Here we go. I'm going to draw a picture of the sun, the moon, and the earth. And again, I need participation, so I'm going to be writing check marks next to your name. I have your list of names on my papers. If you want a homework pass, you need to talk to me. Here is the idea of the sun. Sun's in the middle, and then the earth is going around the sun. And what is wrong with this document? Or what's wrong with this diagram? Go.
Very old. It's not oval, it's circle.
Okay, so Ben
It's
and
almost circular.
say it again, Cash.
Isn't it like almost circular? It's a little bit off.
Good. So the point of this argument is that our Earth does not go in an oval shape around the sun. That's not how it's supposed to be. What it's really supposed to be is it's supposed to be a circle, right? So it's really supposed to be drawn more of a circle. Is it a circle?
No.
It's off by like a little bit.
Very good. Very good. So we're solid there. Thank you.
Not as oval as the.
So the issue is you've grown up thinking that the Earth goes around in an oval path like this because, and I've had this conversation, if I were to ask you to draw the top of my cup, you draw it as an oval, but if I pointed it towards you, you draw it as a circle. So it's a 3D kind of rendering. That's why the artists always draw a circle as an oval if you turn it sideways. And so that's good. So we got that understanding. Good. So let me go back and draw the oval. And again, it's supposed to be a circle, but it's a side view of a circle. And if I were to draw my sun here, what is wrong with my drawing now?
Like the Earth is at a tilt, but not in this photo. It's straight up.
Very good, Wilson. Yeah, so the axis tilt is straight up. If the axis tilt is straight up, how would that affect our seasons?
We would never change seasons.
That's absolutely correct. So all the places on the Earth would have the same season every day. The equator would be scorching hot. It would be uncontrollable. And honestly, that would change our weather and everything else. Good. All right, so now we've kind of looked at what's wrong. Let's start going further now, and let's look at what's right. You should be able to tell me the tilt of the axis, and the tilt of the axis is
23.5 degrees.
23.5 degrees.
Good. So if the sunlight, sorry, and let's kind of continue our conversation. Thanks for being here. It's so good to see all of you, and it's worth your time, I promise. By the way, another thing that's wrong with our drawing is nothing's to scale. The sun is not the size of the Earth. No way, no how. So we just have to get that. All right, so if we have our equator, how is the sunlight here shining compared to the sunlight here?
One's
direct and the other
one's
is indirect.
direct, where if it hits the northern hemisphere, it's indirect.
Holy gosh, you guys are awesome. I might have to start calling on you because there's so many people, but you're right. So if the sunlight's going to be shining directly right here, it's going to make a circle shape. But because of this tilt, the light's going to kind of be spread out, and we call that indirect. So direct on the equator, indirect on the curved surfaces. Awesome sauce. You guys are doing sweet. All right, let's get into the nitty gritty now. Let's teach you something that you probably don't already know. And if you do, let's find out. Okay, so if you could take notes with me, I'd really appreciate that. Everything we're doing now, you're going to notice patterns, and that's what I need you to do. Find the patterns of this. Okay, so I'm going to draw the orbit of our Earth, and if I were really doing it, it'd be almost a circular shape. All right, I'm going to take a minute and do some stuff here. We're going to put the sun in the middle. right? And everything I'm drawing is not to scale, so it's completely bogus. And if you're here, I need you to be appropriate. I want to remind you that. Don't.
You know you can make perfect circles.
You know what? I'm trying to do this as fast as I can, so we're going to do it this way. And that's the, I wish I had a whiteboard right now. So give me a moment to do some artwork here. That's a terrible circle, but we get the idea. All right, I want you to look at this picture right here. And I'm looking at the globe. And this globe on the right hand, there are three main lines that I want you to see. There's the line in the middle of the globe, which would be called the
Equator.
and also there's something called the Tropic of Cancer and the Tropic of Capricorn. And these are new things that we need to talk about. And if you notice the degree of Tropic of Cancer and Tropic of Capricorn, the degree is
The same.
90.
it is the same. And it's also the same as
I don't know.
23 degrees.
It's
It's the same as the
Axis.
axis.
Yep, it's the same as the tilt of the Earth. That's not coincidental, all right? So notice that the Tropic of Cancer is on top. The Tropic of Capricorn is on the bottom. Kids usually ask me why we have these names. I'll explain that to you later if you have that question later. All right, so what I'm going to do is I'm going to draw three lines, and I'm going to color code them. What's wrong with my picture right now? I need to do something else. What do I need to add?
Tilt.
The axis.
I'm going
The
to tilt. Now, what I want you to understand here is that the tilt axis is always facing the same direction. It's not like a top where the axis wobbles. They all face the same direction. And my diagram right now is terribly, terribly wrong because there's no way possible that the Earth is bigger than the sun. Okay, but that's just what I have to do for my diagram today. I can't draw on the bottom half. So, hey, Ben, how do I move this? How do I move this diagram up?
Just click and drag up.
I'm trying to. Oh, there I go. Perfect. Okay, so on my drawing now, I'm going to draw the equator. That'll be the center drawing. But I'm also going to draw a couple other lines as well. I'm going to draw Tropic of Cancer and the Tropic of Cancer Capricorn, and I'm going to shade them three different colors. And I'm trying to estimate approximately, right? So the red is called the Tropic of Cancer. And that's at 23 degrees north. Question. The black is the equator. And then we're going to add one more line. And this is going to be the Tropic of Capricorn. 23 degrees south. What's the degrees of the equator?
0.
Yeah,
0.
good. 0 degrees. Okay. So everybody with me right now, there's really nothing misleading about this diagram. We've got some issues with the sun being too small and the Earth too close to the sun. But other than that, I think we should be in good place. Okay, so, oops, didn't want to do that. Ben, how do I slide this again?
Just select and drag.
Cash, are you laughing at me?
That wasn't me.
Okay, now let's get to the nitty gritty of this. Let me move some stuff out of the way. When I look at my diagram here, I'm looking at my, well, if I were to put marks on these, let's call this 1, let's call this 2, let's call this 3, let's call this 4. Which one of these, and I'm going to call on somebody here. Golden, which one of these would be summer for Ohio? Number 1, 2, 3, or 4? Hi, Candace. Want me to call on somebody else?
Sure.
Charles, which one of these is summer? For
Number
Ohio.
3.
You said number 3?
Yeah.
Okay, Candace, what do you think? Which one of these is summer for Ohio? Candace says number 2. Michael, which one do you think is summer for Ohio?
Number 2.
Number 2. Olive, which one do you think is summer for Ohio?
I don't know.
Take a guess. So far we got 3, we got 2.
Can I change my guess?
Yes, please.
I want to change it to 2.
2, okay?
I guess 2 would make sense.
2 would make sense. Okay, Layla, what do you think?
4.
All right. Audrey, what do you think?
4.
Ben?
4.
Okay. The correct answer for summer would be 4. Let's talk about why. Okay. And so let me zoom out a little bit. And we have something, we have the sunlight, right? And the sunlight is shining all the time on the Earth. And so the sunlight is going to be shining. And I really wish I had a 3D model. It's so easy to see this if we were in class. But in the summertime, the sunlight, oops, I bumped. The sunlight is shining for Ohio and the Northern Hemisphere on that 23.5 degrees north line. Okay, I want to take a moment and take a little bit of notes. So let me change my color. So the sun is shining here at number 4 at 23 degrees north, which means for us, that would be summer in Ohio, right? The whole northern hemisphere would be experiencing summer, okay? And in the summertime, do we have a lot of hours of daylight or a little hours of daylight?
A lot.
of hours.
Yeah. And, well, why is that? And this diagram tells us why. Why do we have more hours in the sunlight?
Because we
Because
have
we're
more
tilted towards the
direct
sun.
sunlight.
Yeah. Take a guess. How many hours of sunlight do we have in the summertime?
16.
Like,
All right.
14.
Good guesses, right? It's going to be around 15 hours of day, right? 10 hours of night. So on this day, there's a specific day, and it's called June. Well, it's usually around June 21st. We call this the June solstice.
I thought it was the summer solstice.
Same thing, right? June is summer. That's the same thing. So June solstice is June 21st, and that is that is the exact day, that specific day where it equals the longest hours of daylight. Longest hours of, oh, I can't write down there. It's not letting me write down there. Go get some water. Longest hours of day. Okay, so on June 21st, the sun is shining at 23.5 degrees north. Ohio is getting the longest hours of daylight. Okay, there's some patterns here. If I were to look at if I were to look at Earth number 2, everything is going to be opposite. Where is the sun going to be shining on Earth number 2?
In the southern hemisphere?
Yeah, and where at? It's going to be shining on the Tropic of Capricorn. So here, the sunlight is going to be shining on the Tropic of Capricorn, which means instead of having very long days, our day is going to be very, very short. We call that winter. Hi, Brick. So on Earth number 2, the sun is shining at 20. Oops, let's change my color. 23.5 degrees south, right? And we call that winter for Ohio. Okay. How many hours? So on this specific day, what month do you think it is?
Winter.
So this specific day would be December, approximately December 21st. this is going to be, if this right here is the longest day, then this right here would be
The shortest day.
worse. So, and we, so the shortest day, and we call it a December solstice, or you might have also heard of it as a winter solstice. So December solstice. We all know that we hate winters because there's not enough daylight. And this season right here, in the summer season, we have 15 hours of daylight. How many hours of daylight are in the December solstice?
10.
Oops, sorry, I didn't want- and the answer is pretty much 10 hours of daylight. And that is not a lot. Is that right? I want to make sure I have that right. No, excuse me, 9 hours. I'm off. 9 hours of daylight. I got to scoot this up a little bit. Excuse me 1 second. All right, 9 hours of daylight. Sorry, excuse me.
Hey, Mr. Nowak.
Yeah, hi.
I'm sorry I missed it.
Hey, Micah, thanks for being here.
I just woke up.
Oh, that's a nice day to wake up. I'm awesome. All right, so we have, let's review. This is summer. Why?
Because
What?
we were sunlight.
Towards the sun.
So the sunlight is hitting at 23.5 degrees north latitude, that top line that's red, and that gives Ohio more direct light. The sun is longer in the sky. Okay. Number two, this Earth number two position. Why is it winter? Because the sun is hitting southern of the equator at 23.5 degrees south. And then we are receiving a smaller daylight. Okay. Are you with me? Am I making sense?
Yes.
Yes.
Okay. So the next question is, if this is summer right here, and this is winter right here, where's fall and where's spring? Anybody want to take a stab at that?
Fall is 3 and spring is 1.
Okay, so if we know the seasons, right? We've learned the seasons ever since kindergarten. We know that in any order, it goes summer, and after summer is fall, and then winter, and then spring, and then summer, fall, winter, spring. We know that everything goes around counterclockwise to the sun.
So then it would be 1 is, yeah, I switch it around.
So if number two is winter, then after winter is going to be, this would be spring. Then we have summer, and then we have up here fall. Sorry, my handwriting's pretty terrible with writing this. Okay, so we have something called the summer solstice. It's June 21st. It's the longest day of the year. We have the winter solstice or December solstice. It's the shortest day of the year. My question to you is, what do you think is going to happen in terms of daylight between winter to summer? What's the daylight going to do?
They're going to be like around the same time as like night.
So I guess the question is I'm going from winter to summer, is daylight going to increase or is daylight going to decrease?
Decrease.
So winter to summer, daylight going to increase. Daylight increases. And from summer to winter, what happens to daylight?
Decrease.
Absolutely. I could so easily, you could start imagining, like, how am I gonna make test questions from this? And it's so evident, like, oh, during which seasons does the hours increase in day? Day decreases here. All right, so do you have any questions? Let me pause for a question. Do you have any question? Okay, so I have a question from you. If it's a solstice, what does that mean?
That the days are the same as it was in the summer or as it was in the fall.
Okay, thank you. I appreciate that. I don't agree with you on that. Thanks, Audrey. What does a solstice mean? I have a solstice right here for summer. I have the June solstice, and I have the December solstice.
When one of them is like the longest day of the year and the shortest day of the year.
That's right. Solstices are recognized as either being the longest day of the year or the shortest day of the year. So if I said, what is the longest day of the year? You're going to say,
June 21st.
Summer.
you're going to say
Solstice.
June solstice or summer solstice. Yeah. Solstice is a word. We're trying to incorporate that vocab. And if I said, what is the shortest day of the year? You're going to say,
Winter solstice.
or December solstice, all the same. And the dates are usually around the 21st, so June 21st, December 21st. There's some fluctuation in that. All right, so now the question is, what happens in spring? I'm going to go to a new board, and I'm going to open up a new board here. And let's, sorry, give me 1 second. I want to kind of quickly redraw that, but not as detailed. And Ben, again, I'm so appreciative of you sharing me this diagram, this website. All right, so we're going to kind of go back and retrace our steps. Here's the sun, all right, and here's our 4 positions of Earth. By the way, I could draw it. I could draw the tilt like this. It doesn't really matter. I could see it on a test. Let's actually take a moment and do that. Which diagram would be summer?
2.
Correct. Which diagram would be fall?
3.
3.
4.
4.
Okay, so like, look, so summer, we know this is going to be winter, right? So and we know that we have to go counterclockwise. So always find summer and winter. How do we know this is summer? Because it's tilted towards the sun. How do we know it's winter? It's pointed away from the sun, the tilt. And so summer, winter, then that tells us right here that has to be fall. And this is spring. Okay, let's do a new diagram. All right, so continuing on, let's talk about the other 2 that we haven't talked about. Let me try to redraw this really quick in a quick manner. So again, sun is in the middle, and we're going to keep everything the same as we did on the other one. So the tilt was going, hang on 1 second. I'm actually going to use that one. Guys, I wish I had a whiteboard. It's so much easier teaching with you in front of class. We're tilted towards the right. Okay, so let's. Okay, so the question is, if this is the summer solstice here, I flipped my diagram, didn't I? Sorry, guys, 1 second. I did. I flipped my diagram. I have to start all over. Thank you for your time. I'm sorry. I'm embarrassed. So this is summer, the summer solstice, and this is the winter solstice. What season is this down here at the bottom?
Fall. No,
Good.
spring.
So now I flip the axis, so it changes the game, and you caught it. So if this is winter and this is summer, this is going to be spring, and this was going to be fall. Now the last word that we need to talk about is something called an equinox. Okay, so equinox. What word in equinox sounds familiar to you? If we could break down the word equinox. Say again? Equal. Yep, Ben got it. Gentlemen, if you aren't interested in learning today, you're welcome to take off. If you want to talk about Fortnite or whatever later, you're welcome to do that. You're here to participate with me. If you're not interested in doing that, then please step away. Okay, so equinox. And equa means equal. And so on a spring equinox and a fall equinox, the day and the night are going to be equal. Ben, can you please stop having that conversation? You're here for a homework pass. If you don't want it, Ben, then I mean, it's up to you. Okay, we're here to learn, not to do Fortnite. Charles, same with you. Okay, starting over, equinox means equal day, equal night. So on the spring equinox, how many hours of daylight are you going to have?
12.
Yep. So a 12-hour day and night.
During the equinox, isn't the sun directly over the equator?
Bingo, Candace. You are money. That's exactly the last thing. The sun is going to be shining directly on the equator for the equinox. Perfect. I'm so glad you added that because I wanted to, but because I flipped my diagram, I left that out. And so because it's shining on the equator, that means that day and night are equal for both of us. So spring equinox, 12-hour day, 12-hour night. Fall equinox, 12-hour day, 12-hour night. Right? Shines on equator. Okay, so there's this myth, by the way, if you're a science person and you like science, there's a myth that you can balance an egg on an equinox. And
I tried that and it worked.
Yeah, so you don't have to wait for the equinox. You can do that at any time. It's really not relevant to the equinox, but I always thought that was fun. Okay. All right, so are you ready for a review?
Sure.
By the way, spring equinox, the date would be
March 21st.
Yep, it's pretty close to March 21st. These days may be a little bit off. And the fall equinox is going to be
September 21st.
All right, I have one more thought. A spring equinox, actually, fall. Let's start with fall. Actually, let's go back to spring. Instead of calling it March equinox or spring equinox, they can also call it a vernal. And vernal means green. So this might be called a vernal equinox, a March equinox, or spring equinox. Okay, so if I'm in a spring equinox, what's going to happen to daylight after that? Will it increase or decrease, Audrey? Spring equinox, what's going to happen to daylight after the spring equinox? Increase or decrease? Ben?
So a spring equinox?
After the spring equinox, will the daylight increase or decrease?
Spring comes after winter, right?
Spring comes after winter. Yes, we are in spring right now.
So it
Daylight.
would increase.
Daylight would increase. What would happen, Brick, what would happen to daylight after the fall equinox? How about Charles? What would happen? It would increase. So Brick, every kid, including you and me, know that around Halloween time, the daylight starts to get shorter. I love Halloween too, and so we all had. Do you agree? You've all had that experience where the daylight gets shorter in the fall because it's heading towards winter. On winter solstice, what happens to the daylight on that exact day of December 21st, 22nd? Charles, what do you know about a solstice? Wilson, on winter solstice, what happens to that day? Talk to me about daylight and nighttime.
Me?
Yep.
On winter solstice, like the days are shorter, and because like it's winter and like the axis is pointed away from the sun, so like we're not getting as much sunlight, thus causing shorter days.
Agree with you, but on the winter solstice, the day and night would be the same. It's good to see so many of you on here. What happens to daylight after a winter solstice?
I think it like there's more of it than
The daylight starts to get longer. So that's the pattern we have. So we have shortest day right here, and then the daylight gets longer until the summer solstice, and then the daylight gets shorter. So you could very easily see me say, after this equinox, what happens to the daylight? Okay, more questions. I'm going to redraw a new, I'm going to go back to our old diagram. On the summer solstice, where is the light directly shining, Kyle?
On the equator.
Olive, do you agree? Summer solstice, where is the light directly shining?
Wait, what? I
On the
got
summer
really
solstice,
distracted.
where is the sunlight directly shining on our Earth?
During what time?
The summer solstice.
Oh, okay.
Your answer is 23.5 degrees north, 0 degrees, 23.5 degrees south.
I think 23.5 degrees north.
Michael Cash, finalize this argument. In summertime, summer solstice, where is the sun
I
directly
think it's
shining?
the trophy of Cancer.
Which would be 23.5 degrees north.
North.
Layla, in the fall, where is the sun directly shining?
On the equator?
Correct. Charles, in winter, where is the sun directly shining? Charles, in the winter, where is the sun directly shining? 23.5 degrees north, 0 degrees, or 23.5 degrees south? Brick, passing it to you. Audrey, passing it to you. Wintertime.
It'd be 23 degrees south.
23.5 degrees south. That's correct. Okay. My last question to you is, can you do me a favor? I'd like you to type in the comments. So go to the comment bar. I'd like you to type in a comment why you think the hours of daylight cause seasons. So what we've learned so far, that there's three things. We've learned that the tilt of the axis affects seasons. We've learned how the light shining on the Earth affects seasons. Well, that last piece that we need to talk about, why does it matter if the hours of daylight are longer or shorter? How does that affect seasons? Please take a comment. Go ahead and type your comment. And this is the last thing we're doing here.
Hi, Mr. Nowak.
Hi, Jordan. So give me a complete sentence. How does daylight affect seasons? You're typing your answer in the comment sections.
Wait, do we all do this?
If you want some kind of credit for being here today, yes.
You said, how does daylight what?
How does the hours of daylight affect seasons? I'm just going to pause and I want to hear your answers. Kyle, what do you mean by that?
So, like, if you have more hours in a day, that means it's going to be most likely summer. And if you have not as many hours in a day, it's going to be winter.
Wilson, can you elaborate, please?
Me?
Yes, I'm looking at your what you typed in. Can you elaborate?
Well, you see, since the sun is a big ball of hydrogen, it's a big ball of burning gas.
Hydrogen and helium, by the way.
It's extremely hot. So if it shines on the Earth more, then it's going to be warmer. If it doesn't, then it's colder.
Okay, I want to pause you right there. You said something. Are there times when the sun doesn't shine on the Earth as much?
Yeah.
Well, be careful with that.
Well, I mean, if you're facing away from the sun, like, you're not going to get as much sunlight.
Does the strength of the sunlight change? That's a very loaded question.
No.
It never does.
In winter, the sunlight is just more spread out than in summer.
More spread out, more indirect. Okay, so Wilson, Still a little bit stuck. I want a little bit more. You said, and I'm going to quote you here, and thank you. It can make us warmer or colder. I don't understand how that causes seasons.
Well, I mean, like,
So the original question was, how does the hours of daylight affect seasons?
well, I mean, it could make the seasons like warmer or colder. Like, it could make it a really cold winter or a really hot summer. Vice versa, a really hot winter or a very cold summer.
Okay. I'm going to read all of your comments in just a minute. I want you to think of I want all of you to think of your oven, right? If you turn your oven on longer, it's going to get a lot hotter. If you turn your oven on shorter, it's going to be cooler. And that's kind of how the seasons work. The last thing that we have to talk about, and looks like many of you have it, when we have more hours of sunlight in our day, that allows us to have a warmer season. And when we have less hours of sunlight in a day, that causes us to have a cooler season. Our cooler season is winter. Our warmer season, of course, is summer. Does that make sense?
Yes.
All right. So again, in final review, we've learned today what a summer solstice is. A summer solstice is when the sun is hitting our Earth at 23.5 degrees north. We have the longest amount of daylight. And that is June 21st, the summer solstice. We have a winter solstice. That is the shortest amount of daylight that we have. It's 9 hours of daylight. That's terribly gloomy and boring. And the sun is shining 23.5 degrees south. And we call that the December solstice. In fall and spring, the sunlight is shining on the equator, and we have equal amount of day and night on the equinox. After a winter solstice, the daylights are going to get longer until it gets to summer. After summer, the daylights are going to get shorter until fall. And if you can take away that message today, then you are a professional seasoned person. That is everything and beyond that you need to know. Okay.
I'll
Question.
be right back, Mr. Noah.
Jordan, this is the end of our meeting. That's all I wanted to talk to you about today. So thank you all for being here. If you don't have any questions, then we are good to go. And for the people that have participated, I'm going to look back and look at the comments. Hopefully you weren't engaging too much in other things while we were having a conversation. So you should see in your email box, hopefully, a homework pass. So I appreciate it, guys. Anybody have any good things to share before you all take off?
I'm getting a new phone.
You're getting a new phone. I'm gonna stop the recording here. Give me 1 second. That's cool. A new phone.